Our next topic is to learn about reliability, validity, and precision. And I really want to emphasize we're talking here about the epidemiological definitions and understanding of these terms. Please do not confuse these with meanings that might be applicable in lay speak. So there's a lot of confusion in the published accounts. It's not that some are right and some are wrong, it's just different points of view. In this video, we're hopefully going to get a very clear-cut and less confusing explanation of what these terms are all about in epidemiology. The first of these terms that we're going to deal with is reliability. Reliability is another word for repeatability of the measurements. So an example, I was involved in a study where we performed urine tests for HIV, and then they were repeated, and we found that some people in between the two tests had inexplicably gone from positive to negative, others had gone from negative to positive. The overall percentages that were positive remained unchanged, but at an individual level, the test was unreliable. Now, you'll see somewhere in other books, people also talk about reliability as referring to the repeatability of summary measures or of experiments if done over and over. We're not going to worry too much about that. For us, reliability is the repeatability of test results at an individual level. The next concept is the concept of validity. And validity is a measure of how close your results or findings are to the truth. It's also sometimes called accuracy. For example, if you ask people in a questionnaire to answer certain questions and all the people don't understand the question in the same way, it's a bit ambiguous, you may not get a valid response in some cases. Or if people decide to conceal the truth because they're worried that somehow someone's going to find out who answered this questionnaire, then again, you may not get a valid response. Some people, out of a willingness to please, may not know the answer, but they'll make up an answer. Again, this will affect the validity of the response. So you have to be very careful when asking people questions, but also when performing laboratory measurements, that your methods are actually also correct and that they're going to give you valid findings. One comes across very long lists. I once saw a list of 30 different kinds of validity. However, we'll concentrate on the most useful ones, I think, here. Face validity means when I look at it, does it make sense? In other words, based on my knowledge and experience, is this likely to be the truth? It might be, for example, that I will accept what's written on a birth certificate, the date, as being the date of birth. Content validity is more often encountered in the context of social or sociological questions, the social sciences, and in psychology, when you want to develop a score to describe a particular variable which can't be measured directly. And you do this by asking a variety of questions and then combining the responses and developing a score or an index in some way. And the content validity depends on whether or not you've included all the relevant components that will validly represent the construct that you're trying to measure. And also it depends to some extent that you don't include some irrelevant components which shouldn't be there. Criterion validity is when you have a final score or a measurement and you want to know how well does this overall measurement or test compare to a gold standard. Of course, this is only testable if you do have an acknowledged gold standard. Predictive validity depends on whether or not an instrument that was intended to predict something actually correctly predicts it. For example, if you want to know whether a particular measure or risk measure would correctly predict whether a woman would give birth to a child with Down syndrome. You actually want to see how accurate is your prediction. Does this score actually validly tell you whether or not this lady is going to have a baby with Down syndrome? So that would be the predictive validity. You can read more about this in Ehrlich and Joubert. This is a little diagram to show relationships between reliability and validity that we've been talking about. For example, if something is valid, then you would expect the measurements to be distributed around the truth and not biased in any way. If it is not valid, you'd expect the measurements, those little blue dots, to lie away from the truth, which is represented by the red line. On the other hand, if a test is very repeatable or reliable, you'd expect all the little blue dots to be close together. And if it's less reliable, you'd expect the little blue dots to be widely spread. We come now to the concept of precision. And I want to try and avoid getting confused between precision and reliability. So precision, when we use the term precision, we're talking about a narrow confidence interval. This could be for a point estimate, for example. Now you're going to learn more about confidence intervals as this module goes on, and as you do the next module, you're going to learn about how to calculate them and what they actually mean. But we want a narrow confidence interval for our estimates, and then we will say that this is a more precise estimation. If that confidence interval is wide, we say it is less precise. There's less precision. I won't go into that further here, but you will learn more about this in the next few weeks. Now, the main factor that affects parameter precision, estimate precision, is the sample size. So if you have a bigger sample size, you'll get a more precise estimate. That's by far and away the most important way to reduce precision. Get yourself a bigger sample, and that'll give you a more precise estimate. However, if the natural variation inherent in individual samples is great, you're going to have a less precise estimate. In addition, if the individual measurements are less repeatable, then you're going to get less precise estimates. You're going to learn about this in greater detail in the next 2 weeks, so don't despair if it seems a bit opaque at the moment. In summary, reliability is the same as repeatability. It says, do we get the same test result if we do the test over and over again on the same person? Validity, are we measuring what we intend to measure without bias? Is what we measure close to the truth? And precision, how confident are we of our parameter estimates which we obtain from samples? How confident are we that this is in fact the truth?